Welcome to our first actual lesson on statistics. Today we're going to be taking a look at representing data, which is basically a fancy name for saying we're going to be looking at putting together some charts and graphs and stuff like that. Interesting fact, when statistics was first kind of invented and people started collecting information about stuff, all they did was write down big lists of numbers and data in tables. They had no way of representing it at the time, which means if you wanted to know what, say, for instance, birth rates looked like in a country, how many boys, how many girls, you'd have to just read pages and pages of boy, boy, girl, 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 boy, girl, etc. They didn't really condense the data; they just collected it. Now we do things much nicer. We like to put things into very standardized, very neat little tables, and then we like to make graphs from them that are easy for people to see and understand. So a lot of the things in this course, and I'm going to show you through this unit or this lesson at least, um, the words on the screen, the words in the notes are there for your reference later. But a lot of times I'm going to jump into examples and then just reference those ideas as I go through the examples, rather than try and teach you a bunch of words out of context and then jump into examples after that. So let's start off by making a frequency table. And I've got a set of data here, or sorry, I have a blank table with no data. Now, if we were in a classroom, I would actually go around the room and ask people different information about themselves and collect it and put it on here. Unfortunately, right now, I'm going to have to make a little bit of this up since I have no real data to work with. But I got some pretty good ideas of what's out there. So for this first example, I would normally go around and ask each student what video game systems they owned. And that's what I would collect. Now you'll notice that at the top line there, I've got my system and I've listed some systems that are relatively common, even though some of them aren't particularly common anymore. I've got Ataris, Nintendos, Sega, Xbox, PlayStation, and I put other because often in these questions somebody comes up with something interesting and I like to write that down. Um, so what I would do is maybe go to the first person and say, "Do you own any video game systems?" And they say, "Why, yes, I do. I own a Nintendo and a PlayStation." So I put a little tick mark there and one there. And then I ask the next student, "Do you own any video game systems?" And they say, "Yeah, I own a PlayStation." So I put another tick mark there under PlayStation. And this tally row is really not necessary to keep in any kind of formal final step of a table. In fact, you'll never see them in my examples from here on in the rest of the course. They're just basically a way to put little tick marks as I'm collecting data. Now, another way I could do this is to just ask my class, everyone who's got Atari, put up their hands. And let's say I see, okay, 1, 2, 3 people put their hands up for Atari. So I say the frequency is 3. And when I say Nintendo, oh, lots of people have Nintendos of some kind. So I'm going to say there's about 11 of those. So if I was making my tally column or tally row, I would do that. Again, not necessarily necessary. Anyone own a Sega? We'll say 4 people own Segas. Xboxes, fairly common. Let's say there's 13 people. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And PlayStation, we'll say there's the PlayStation people always get upset with me if I put down more or less PlayStation than Xbox. So I'm going to say 14. 1, 2, 3, 4, 5. 1, 2, 3, 4 for a grand total of 14. And then other, again, there's other video game systems out there, probably lots you haven't heard of. Magnavox Odyssey 2. There's the Morgan or Fairchild Channel F. There's the Vectrix. There's a whole bunch of. I'm going to say one other student has an other system. Okay, so that's it. To make a frequency table, we basically list the possible outcomes, the things that we're looking for. Again, I put down these particular systems because I thought that kind of covered all the major categories. If someone in my class said something specific, I might make a couple more rows in that, or a couple more columns in that table just to fill it in. But that's basically a frequency table. It tells me what the things are and how many I've got of them. 3 Ataris, 11 Nintendos, and so on. Now for bar graphs and bar charts, I'll usually refer to them as bar graphs, but it doesn't matter, they're the same thing. They're a way of representing relationships. And again, there's words on the screen there, but I'm not going to bother walking through them, I'll just start jumping in and showing you what it looks like. So, oh, hold on. Produce it. That's not what I wanted to say. Okay, that's better. Ah, the magic of editing video. Okay, example 2. Produce a bar graph for the video game systems owned by the students in our class. Okay, so what I'm going to do here is I'm just going to make essentially a graph. Looks a little bit like the XY graphs you make. I'm going to apologize. I'm writing on a digital screen. It's a little bit trickier than writing on pencil and paper because I'm kind of writing with my hand in the air on a 45-degree angle. But what I'm going to do is I'm going to make a bar for each of the different video game systems that were there. So if I just scroll up a little bit, the first thing I really need to make note of is that I want my scales to work out nicely. So in this case, the largest value I have is PlayStation's at 14. And one of the rules I'm going to make when I'm choosing my scale is that I want to go up by ones, twos, or fives, or powers of 10 of those. So like 10, 20, 50, 1,000, 2,000, 5,000, or 0.01, 0.02, 0.05. We don't want to go up by threes or sevens or 11s or 22.8s because it's messy. Since the largest number that we have is 14, I could go up by fives and go 5, 10, 15. However, that would only make 3 tick bars, and that doesn't seem like enough. So I'm going to go up by twos and go 2, 4, 6, 8, 10, 12, 14. 2, 4, 6. All right. And we work with the space we've got. So if we have enough room there, we made it up to 14, that's fine. And if we didn't, then maybe going up by fives would be sufficient. We go 0, 5, 10, 15. I'm not going to bother labeling the actual graph itself, like naming the graph, because I think it's pretty self-explanatory from the questions, and I never actually label the graphs when it is. I am, however, going to label my axes to make sure that it's clear. And along the bottom here, I have systems, specifically video game systems. And here I have number of students that own them. And this side, regardless of what it's actually called, is going to be the frequency. So in this case, I'm counting the number of students who own each system. That is the frequency of each system. And then I'm going to make my little list here. I've got, what was the order I had them in up here? Let me just double check. Atari, Nintendo. You know what? In fact, I think we're safe in this case to just put the first letter of each if it's obvious. Atari, Nintendo, Sega, uh, PlayStation, no, Xbox, PlayStation, and I'm going to actually write the word other. I never like using O as a single letter because it looks like a zero. But either way, as long as we've labeled these. And now I look at the numbers again and I just say, okay, for the Atari, there were 3 students that owned Atari, 11 for Nintendo, and 4 for Sega. So 3, 11, 4. So I'm just going to make a bar that's approximately, let's try that one more time. 3 tall. And I'm going to shade it in just a little bit, just to make it a little clearer. I think it looks better when you shade them in just because it doesn't get it mixed up. The next one's going to be 11 high. And you'll notice that I'm putting very little effort into making sure that these are super accurate. They're just approximations. They're for visual effects. I didn't use a ruler. I didn't use anything like that. So 3, and this one's 4. I am trying to make them approximately the right height, and I try to make them approximately the same width as each other. And I will point out that it's important that I leave a space in between each bar. It's actually one of the things that we want for our bar graphs. This in particular is a non-numeric data set. The Atari Nintendo have no particular order or numerical meaning. The frequencies are always going to be frequencies, no matter what I'm measuring, whether it's heights, weights, colors, whatever. But I do not want these to touch, and I want them to be approximately to write everything else. Okay, then we got 13, 14, and 1. So 13 puts us around here. 14 goes just a little higher and a little off center there for the P. In fact, I'm going to correct that because I really want to emphasize that the labels for each of these should be centered on the bars. In a bar graph, the labels always get put underneath the middle of the bar that they represent. And then down here, we just have one for other. Okay, and that's about it. So the things that I want to just point out before we move on are make sure that you actually do put the labels on there to tell me what the vertical and horizontal axes are. Make sure that your numbers go up by ones, twos, fives, or powers of 10 of those. So make sure that your scale is reasonable. And in a bar graph, make sure that your labels are underneath in the center of each bar. And that's about it for bar graphs. Okay. All right, moving right along. I'm going to do another bar graph, but I want to just talk about something that you can add to a frequency table. Not all frequency tables will have these, but you might do it sometimes or you might see them. They're called cumulative frequencies. And the idea of a cumulative frequency is that it's all the data up to that point. So now in some cases, it doesn't make sense because if I look back at the data that I just had, the third bar, the third piece of data I had was the Sega system. Now, I can't say who has anything up to and including Sega because I don't know what that really means. What's Sega or less and what's more than Sega? So for non-numeric data or ordinal data, things that don't have, nominal data, things that have no order to them, it doesn't make sense to talk about cumulative frequencies. But if our data is ordinal or if it's interval, then we can use cumulative frequencies. So for this particular one, we're going to take basically I would go around the room and ask each student how many video game systems they owned. And many students will own one, some will own none, some just play on their computer, or some don't play video games at all. Some weird students, I don't understand them, but there's the occasional person who doesn't play video games, and we'll let them be them. I left this one kind of vague because I never know how many answers I'm going to get. There could be a lot of other possibilities. Fun fact, I own over 100 consoles. I don't know how many of them are different. I got a bunch of repeats, but I own over 100 consoles. So I would really screw up this table if I was actually including my data. But we'll assume that most students own, let's say, up to about 5. And I'll pretend that every student in my class who gives me a number that's between 0 and 5. So if that's the case, these are the possible outcomes. And again, if there were a student that had 6 or 7 or 8 or more systems, I might include them in this table. But for the simplicity of this, I think I'm just going to leave it at that. Frequency, let's just say there are 3 students with no systems, and there are 5 students with 1, and 6 students with 2, and 9 students with 3, and 2 with 4, and 1 with 5. Okay, so now we get into the cumulative frequency idea. So the number of systems of 0, there are 3 students who have 0 or less systems. That's what it means by saying cumulative, up to and including 0. Now, when I say how many students have up to and including 1 system, there's the 3 students that had no systems and 5 that had 1, so there's a total of 8. So basically, I just took my previous cumulative frequency and added the new value. So I took the 3 and added in the 5. For 2 systems or less, I'm going to take my previous cumulative frequency of 8 and add 6 more to get to 14. I'm going to take that and add 9 to get to 23. Plus 2 is 25. Plus 1 is 26. And again, this is a way of quickly saying to anyone who's looking at the data that all the data, basically, I now know there's 26 points. I could have figured that by just adding the frequencies up before, which is kind of essentially what we did. But in this case, I said, let's let's just do the cumulative frequency. So 26 students in my class, which would be all of them, have 5 or less video game systems. And then I can also say things like there's 23 students in my class that have 3 or less video game systems. All right, now that we have that, let's make a little bar graph of this information. So we'll start the same way we started before. I'll even try to make it a little bit straighter than the last one, give or take. We have our graph. Now, in this case, our largest frequency, the cumulative frequencies are nice to have there, but they're not actually going to come into play when we're making our graph. We're just going to look at the frequencies, and I think the biggest number I see is 9. So going up by ones, I could go 0 through 9. And you know what? I think that might actually fit here. But just to save a little bit of writing and space, I think I'm going to go up by 2s again and go 2, 4, 6, 8, 10. Of course, if you had graph paper, you could do this a little bit more accurately, but again, don't really care for the understanding of how these work. Okay, so across the bottom, I'm going to have number of systems. And across the side, I'm going to have number of students. And again, that's the frequency in this case. Okay, so now my possible outcomes, much like I had different types of systems before, I can have 0 systems, 1, 2, 3, 4, or 5. And again, since it's a bar graph, our last one was non-numeric data. This one is discrete data, but it's made the same way. The only real difference now is that the numbers actually have some meaning, so the order of them makes sense. Before, I could have put Nintendo first, last, or in the middle. It didn't matter. Here, 0, 1, 2, 3, 4, 5 definitely makes more sense than putting these numbers in any other order. 0, 5, 3, 4, 2, 1 doesn't make a lot of sense. But I'm just going to make the bars for them the same way I did before. So frequencies are 3, 5, 8. And again, I'm leaving a little bit of space between the bars. That represents that this is discrete data, which means that the data does not flow nicely from one value to the next. It jumps. You have one system or two. No one has in between those numbers. So we leave a space to show that there is no in between value. Oh, wait, where did I get that 8 from? That should only be 6. My apologies. Not the first mistake I've made, not the last one I will make. 3, 5, 6, 9, 2, and 1. All right. It's probably a good place to mention I am mildly dyslexic, so I tend to look at the wrong numbers all the time. In this case, I looked at the 8 instead of the 6. I also tend to get numbers backwards, but luckily, video editing, and usually I catch them anyway. Okay, so there we made a bar graph for non-numeric data. We made a bar graph for discrete numerical data. Our next step then would be to take a look at something called a histogram. And there looks like a million instructions here. So we're not going to stop and look at this too much. I'm going to jump to the example, make a histogram, and point out the important things as we get here. I will start by pointing out, though, that this is for continuous numerical data. That is the key feature here. Histograms are used anytime our data is continuous. All right. So I will also point out these numbers may look a little bit larger on my screen than they do on your printouts, and that's because I wanted to make sure it was clear on the video that you could see everything nice and neatly, so I made it a little bigger and formatted it slightly differently. So here's a data set that I got. It's the weight in pounds of the Tampa Bay Buccaneers, and I took this from the 2021 Super Bowl results. So we can look at this data, and usually, not always, I will put the data in order for you from smallest to largest or vice versa, so that it's a little bit easier to kind of find everything you're looking for. Here we have weights going from 170 all the way up to 347. So when we're given this much data, two things. First of all, we could produce a bar chart. Well, no, we can't, but let's pretend we could produce a bar chart for this, pretending this was discrete data. There would be a lot of bars, and that would be a problem in and of itself. The other problem, though, is that these are not actual exact weights. The person who, for instance, is 170 pounds is not 170 pounds. It's not a discrete number. Weight is a continuous concept. That person is likely between 169 and a half and 170 and a half pounds. So we don't know exactly where in that. We just know that they're around 170, when that we've chosen to round off to the closest whole number. So here's the way I kind of want you to think about this. Pretend that we're going to do something called bins. So pretend that you literally have like buckets in front of you, and you're going to have different buckets for different sizes. Now, this is a little bit hard to visualize if you're thinking about football players. So let's just back off a second. Say that you're fishing. You're fishing and you've caught a bunch of fishes, and you've got a bunch of buckets in front of you. And the first bucket is for fish that are 0 to 2 pounds. So you catch a small fish that weighs a pound and a half, you throw it in that bucket. Your next bucket is from 2 to 4 pounds. So you catch a fish that's about 3, you throw it in there. And then you've got a different bucket for each different size category of fish. Well, here we're going to do the same thing. We're going to choose bins, and we're going to give them a size. We're going to have a minimum and a maximum, and we're going to choose an appropriate number of bins. Now, in real life, real data, sometimes you can have a lot of bins. Usually, though, the rule that we're going to use in this course is going to be 5 bin minimum, 10 bin maximum. Anything less than 5, like if you only make 2 or 3 bins, it doesn't really show a distribution of data. It just shows 2 bars or 3 bars that are all there. It doesn't really show how it's broken down. You might as well just make 1 bin and say that everything's in it. Likewise, if we make, say, for instance, in this case, 50 bins, each bin is only going to have like 0 or 1 or maybe 2 things in it. So we don't want too many bins. And 5 to 10 bins is our sweet spot. So I'm just going to point out that our minimum is 170 and our maximum up here is 347. So those are about 177 apart. And we want to break that down into 5 to 10 chunks. Now, if I did 5 chunks for 177, that would give me 30 something ish. And again, I don't want bins of 30 or 30 width. Good scale is always that 1, 2, 5 rule. So we need them to be bigger than 30. So the next number that kind of works nicely is 50. So we could start at 150 and go up by 50s. And the reason I say we start at 150 is you always start at a multiple of whatever it is you're going up by. So going like 170 plus 50 is 220 to 270 is messy. Doing 150, 200, 250, 300 works out nicely. So we could do that. If we do that going up by 50s, we'll have bins starting at 152, 253, 350. Oh, wait, 3. I think that might be all. 150, 2, 250, 3. Yeah, I think we're going to get everything into 3 or 4 bins. So maybe we don't want to go up by 50s. Maybe we go up by 20s, and then 177 should go into about 8 or 9 bins. So I think that's the way to go, is that we're going to have all these bins. Now, don't write this down. I'm just going to draw a little conceptual picture. So we're going to think of these as bins, a whole bunch of bins, and we're going to go up by 20. So they're going to have ranges of 20. So anything in this bin is going to go from, now we have to fit 170 in, that's the smallest number. But again, we have to start at a multiple of 20. So I'm going to start at 160 to 180. Now, some people are going to say that, okay, so the next bin should start at 181 because we can't start at 180, it's already taken. But we don't start at 181 because that would suggest that anything between 180 and 181, which obviously there are people that weigh between those, even if they're not in this group, we can't leave out gaps because this is continuous data. So this is actually going to be 180 to 200. And this is going to be 200 to 220. And our last one should be 340 to 360. Okay, so that's the idea of our bins. We choose a bin width that's appropriate for the maximum and minimum data point that we have to fit in. Again, should go up by ones, twos, fives. We choose a starting and ending point that are both multiples of that number. In this case, everything's a multiple of 20. And then we just figured how many things go into each bin. So now this is where I'm going to erase this part. And I'm actually just going to start by drawing the frequency table. I'm not going to actually complete the frequency table because there's a couple things that we need to figure out first. So I'm going to set this up much like a bar graph would. Very similar to our bar graph. You know what? I really don't like the fact that I made that such a bad straight line. Okay. So I said we're going to start at 160, and I'm going to go up by 20s. Now, if I'm going to show you don't have to do this, but if it happens, you can do this, where you've got 160, 180. Sometimes I do a little bit longer thing. It's just so that your numbers don't look like they're flowing into each other. If you've got room to write the numbers and not have them look like, I don't want it to look like 160, 180 as one continuous number. So I just kind of go up and down a little bit. Sorry, it's just a little low on my page there. 210, 220. Oh, I did it again. Okay, got to go up by 20s, not 10s. 220, 240, 260, 280, 300, 320, 340, and 360. Okay, so I think that fit in all of our numbers that we have to get from 160 up to 360. Our smallest number actually being 170, our largest 347. Now what I need to do is figure out how many things are in each of my bins. So from 160 to 180, I'm going to kind of just underline them here. I have 1, 2, 3, 4 things. Now, rather than make a frequency table separately, I'm going to just secretly, quietly put a 4 there. There's 4 things that are going to go into that bin. 180 to 200, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the rule that we're going to use is that whenever a number, like in this case 200, is exactly on the line, it's going to go into the next higher bin. So we're going to save the 200s for the 2 to 220 bin. So our 180 to 200 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So again, I'm going to write that there. And then our 200 to 220, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 21. And I'm just going to use the video editing to do the rest of these quickly to save you a little bit of time. And you can catch up with me in, well, for you, it would be no time at all. All right, and just like magic, I've gone through and done the frequencies for each of the other different bins. So we have 4, 10, 21, 12, 9, 6, 6, 16, 4, and 1. Hopefully I counted right. Usually I do, but not always. Okay, now that I see what my biggest numbers are, in this case 21, I can decide what I'm going to go up by. Now in this case, I could go up by 2s, but then I would need 11 tick marks going up. And despite the fact that going up to 5s and only having 4 or 5 tick marks seems like a lot, I don't think I'm going to be able to fit much more in. So here I am going to go up by 5s. So 5, 10, 15, 20, and 25, even though I don't need to go past 21. And here the frequency is the number of players. I don't really need these weights on the screen anymore, so I can kind of move this up. In fact, I'll make this a little larger just so it's easier to see. And I should label this one, and this was weights in pounds. Okay, so now I'm going to make the bars, and I'm going to point out the differences between this and the bar graph. So this is going to be a height of 4. It goes from here to there. Now you'll notice that unlike last time, and see when I crosshatch it, it covers up the 4, so it doesn't even matter that I wrote it there. Unlike the last time where I took a bar graph and I labeled each bar in the center of the bar to show that it was discrete or non-numeric, here I'm not labeling the center of the bar, I'm labeling the sides of the bars. This bar starts at 160 and it ends at 180, and that represents the continuousness of the data. Now the next bar goes up to a frequency of 10, and it's actually going to be touching. And again, the fact that it touches, whoa, why did it do that? Apparently I can make straight lines by accident. Okay, so it's going to touch the original bar to show that it flows nicely past 180. You can have numbers that go right up to 180. You can have 179.999 and you can have 180.0001. So it's to show that they touch, and that again represents continuous data. The next bar goes up to 21. Can just kind of eyeball it. The next one, 12, somewhere around there. Again, if I was really wanted to do this, I was getting marked on it myself for university or something, I might use a ruler, but I'm not going to dock you marks for having it slightly messy as long as it's reasonable. 6, 6, and then, whoa, this one goes all the way up to 16. And finally 4, and the last one's just a little 1. Okay, so there's my histogram. A couple things I'm going to point out. Our scale that we chose, going up in this case by 5s, follows the same rules as it did for bar graphs. I still label both axes, my frequency, in this case number of players, and my whatever it is I'm measuring, in this case weight in pounds. I make sure those labels are on. And the difference really here is that the bars do touch to represent the continuousness of the data, and the bars are all labeled at the sides of the bars, the breaking point between bars, not in the middles of bars. So those are the two key features that I want to point out when you're making histograms. So they may seem like they're a little bit more difficult. They actually are not too bad. The hardest part really is figuring out how many bins to make and your bin widths, but even that's not too tricky. So I'm going to do one more example, and this one I'm going to shoot through again fairly quickly. So this one here happens to be real data as well. I happen to like the band Avenged Sevenfold, so I went to my playlist and actually recorded the lengths of each of the songs off the list just to see how long they were. I won't say that I think this is all of their albums. I can't remember if I included any songs or not. And you'll notice that the smallest song, or the shortest song, I should say, was 72 seconds long, and the largest one up there is 941. Now, I'm going to bring this up in another lesson later in the future, but I think I'll mention it now. If we take a look at the last couple songs, we go from 554 seconds here to 657. Now that's over 100 jump. That's about a 20% increase in song length. And then we go from 600s up to 900s. That's a 50% jump in length for just 2 songs, given a large data set. Normally what we would do is consider listing some of these as outliers because there's such a big jump from the previous values. I think I'm going to show you something, or basically do it the way you would expect me to do it this time, and I won't throw them out, but I want you to see what happens. Okay, so in this case, I actually think the numbers are pretty easy to work with. We're going from 72 to 941. It's almost 1,000. I think it's safe to say that I'm going to go up by 100s and have 10 bins. If I went up by 50s, I'd have closer to 20 bins. That's too many. If I went up by 200, I'd have 5 bins. That's doable. But I think you'll see with the outliers there, it's almost ridiculous if I do 5 bins because all the data will be in the first 3. So here, I think I'm going to just do bins of 100 and go up by 10s. Sorry, go up by 100s. Make this one a little extra long. So 0, 100, 200, 300, 400, 500, 600, 7, 8, 9, and 1,000. And that should include everything. Again, I'm going to just kind of go through and get the frequencies off here alone. Remember that any number that's exactly on a breaking point, we can see in the middle here, there's several songs that are actually 300 seconds long. And I can guarantee you that if you actually looked at them, none of them are 300.0000 to infinity seconds long. They're all 300, give or take a half second. So whenever we're not sure, 300 goes into the next bin up, so it'll round up to the higher bin. So just give me a moment and I will figure out the frequencies for both of those and I will be back with you. Okay, so the frequencies I got for each of the intervals were 22, 22, 35, 11, 4, 1, 0, 0, 1. All right. Now that I can see that the largest one is 35, I can choose to go up by something reasonable. Going up by 10s would only give me 4 tick marks. Going up by 20s would only give me 2. I think going up by 5s is probably the good way to go. So 0, 5, 10, 15, 20, 25, 30, and 35. Again, I don't really need the numbers anymore, so I'm just going to kind of move up here. I do need to label my axes though. This is the length of the songs in seconds, and this is the number of songs. It's not wrong to write the word frequency there, but number of songs is a lot more specific, and it's always better to have, things that are labeled nicely. Okay, so now we can fairly quickly just say, okay, that one's too high, so is that one. Make sure the bars are touching. They're already labeled at the ends. This one goes all the way up to 22, so about here. This one goes up to 35, way up at the top. This one only goes to 11. And then, I don't know, 4, 1. The zeros don't even get anything. I should erase them. It doesn't matter. Having those numbers there kind of visible is not going to hurt anything. And again, it helps actually read and make the graph, so we'll leave them there. Okay, so that's what the histogram looks like. Now, I'm just going to show you that if we had considered those last 2 songs outliers, if we had done that, all it would mean is that we would basically ignore this part of the graph. And I think you can see that as far as visually representing what kind of common song lengths the band has, ignoring that little bit at the end really doesn't change your perception. They have 1 or 2 songs that are particularly long. In fact, I only cut out the very last song there. And even if I'd cut out the one here, I don't think it would make a big difference to the representation of the body. But you can leave them in, or you can take out outliers if you'd like. Again, we'll talk more about outliers in a future lesson, so we can leave it there for now. All right. One little last thing that I kind of want to talk about, and that's doing bar graphs with bins. So this is kind of using a very similar idea to the bin width, except in this case with bar graphs. And what we're going to do here is just say we've got a bunch of data. We don't want to make a typical bar graph, even though this data here shows the number of points scored by each of the Toronto Maple Leafs during the 23-24 season. It is discrete data. We should make a bar graph for it, and we're going to. These are our data, but we don't want to have to make a bar for every possible different value because we have 1, 2, 3, 4, 5, 6, 7, 8, 19 data points. And I think the only ones that repeat, the 19 shows up 3 times, and that's it. So with 19 data points, we'd have 17 bars. Almost all of them would be 1s. We'd have to put bars in between because even though it's where we've got someone who scored 5 goals and 6 goals and 10 goals, we should have a 7, 8, 9 in there if we're kind of making the graph representational. So we are going to want to put these into bins as well. Now, in this case, unfortunately, I put the numbers highest to lowest, but we can still read off the numbers the way that we want to. And again, we're going to go basically between 0 and about 110. Going up by tens might be a little too much because then we're going to have 11 bins. I think in this case, we're going to go up by 20s. So here's what we're going to do. I'm going to set this up. And I want to again point out that this is going to be a bar graph and not a histogram. So here we actually will separate the bars to show that there is no continuous jump from one number to the, or continuous flow from one number to the next. It is jumping. There, for instance, our first two data points, or end two, I guess in this case, are 5 and 6. No one scored between 5 and 6 goals. It is impossible to get between 5 and 6 points. So we don't want to have the bars touching, and we don't want to label them at the edges. So what I'm going to do is just say I'm going to go up by 20s, and I'm going to say my first bin is going to be 20 numbers wide. And this, you may have to think about this for a second, but my first bin is actually going to be 0 to 19. You know what? Actually, we're only going to do like 5 or 6 bins. I think I can spare the room and say 0 to 19. I can't say 0 to 20 because that's actually 21 numbers, right? Because 1 to 19 is 19 numbers, the 0 is another one. So there's going to be one bar there. Then the next bar is going to be 20 to 39. Now you'll notice that with histograms, we had to start and end off a bin and start the next bin at the same number to show that it's continuous. Here, I can stop at 19 and start the next one at 20 because there is no such thing as 19.4 goals or 19.7 points. The next one's going to be 40 to 59, 60 to 79. We have to extend this a little bit. 80 to 99, and 100 to 119. Okay, so it's still following the rule of we made our bins 1, 2, or 5 wide. In this case, we're making them 20 wide. We're talking about 20 discrete numbers, not a distance of 20 between the top and the bottom number. The fact that they end off at the 9s, it doesn't matter. It's just the way it is. But they're starting at a multiple of 20. They're 20 wide each. And we're going to basically figure out the bin or the number of things in each of these. So 0 to 19. Now, this case, 19 doesn't round into the next one because 19 is an exact value and it falls into the first bin. So we have 1, 2, 3, 4, 5, 6, 7 things in that bin. 20 to 39. 1, 2, 3, 4, 5, 6. 40 to 59. It's just the 2. 60 to 79, just the 1. 80 to 99, there's 2, and then there's 1 up there. Okay, so in this case, the largest value we have is a 7. I think it's safe to go up by 1s in this case. All right, and then we just start making our bars. So our first bar is going to be 7 high. And despite the fact that my label below it is a little bit wide, it is centered on the bar, more or less. Second one is 6 high. And then 2 high, 1 high, 2 high, and finally 1 high. So that's how to do a bar graph with bins. Basically, when there's too many different intervals that you have to work with, you can't list everyone. Like there's no way we were going to make 107 bins on this one, and then all of them except the 19 would just be 1 unit high. This shows a better distribution of scoring. So we can see that lots of people scored very low, and then there were a few people that scored quite high. All right, we're getting close to being done here, thankfully. So the last thing I want to talk about really quickly is pie charts or circle graphs or circle charts or pie graphs or whatever you want to call them. Basically, they're round. So in this one, we're just going to take student hair color as our example. And I'm going to just kind of make up some data again. I have no idea how many people have which hair color in the class. I guess I could try and figure it out, but I'm going to just make it up. And I'm going to say that there are 12 people with black hair and there are 7 with brown hair, and there are 5 people that are blonde and 2 redheads. And I teach at an art school, so let's just say pink in there because I very seldomly have a class without a kid with pink hair. We'll say there's 2 of them, and I don't know, 1 person with green, just for the heck of it. Okay, now as far as the fraction of students goes, I need to know how many total number of students there are. So I just add up the number of students in each of the columns. 12 plus 7 is 19, 24, 25, 26, 27, 28, 29 students in total. I'm just going to make a little note of that down here. And then what I'm going to do is just say, well, this fraction would be 12 out of 29, 7 out of 29, 5 out of 29, 2 out of 29, and so on. Now, why is that relevant? If we're trying to figure out how big a piece of pie we need to make for each of these different hair colors, we need to know the fraction of a whole. So most of you probably know that a circle is 360 degrees. So all I have to do is say whatever 360 degrees is, I need 12/29ths of it. So 12 divided by 29 times 360. And that gives me 140, I'm going to round off to 149 degrees. I think being within a degree on each of these is more than accurate enough. 7 out of 29 times 360 is going to be 87 degrees. And then the rest, if you'll forgive me, I'm not going to bother writing down the math. I'm just going to write down the answers. So this one's going to be 62 degrees. 2 out of 29 times 360 is 25 degrees. This is going to be the same, and that's going to be roughly half. It was actually 24.8, so this will be 12.4 and round off to 12%. I'm sorry, 12 degrees, not 12%. All right. From there, we're going to make a little circular graph. So I'm going to just start by making a circle to the best of my abilities. It's going to look like that. Okay, and I don't want you to think too long and hard about any of these values. I want you to kind of just approximate them. So what I often do, at least in my head, and I'll kind of just do it here, I'll use, I don't know, red, just to show. I usually like to break the circle into 4 90-degree segments. It's just a little bit easier for me to imagine the different angles in my head then. So the first one, the black hair, is going to be 149 degrees. Well, 149 is going to be 90 plus 60, so it's going to basically be the 1 whole quarter plus about 2/3 of the remaining quarter. So I'm going to say that this is black hair. Now, there's no rule that says they have to appear like clockwise or counterclockwise in the same order as anything else. I notice my next one's 87. That's very close to 90 degrees. So what I'm going to do is just shave a little bit off of there and say that this is the brown-haired students. The blondes make up 62 degrees. Again, 62 is about 2/3. So I'm going to say something like that will be the blonde. And then we've got two 25s and a 12. So with this last piece, those are approximately equal on the left and right side of the dotted line. So what I'm maybe going to do is just say, think of break this into like 5 pieces. And 2/5, 25 degrees, 25 degrees. Oop, sorry, that one. Actually, that's fine. That just has to be the smaller one. Okay, so that little one down there is the green. And then this can be the pink, and this can be the red hair. If you really want, you can, by all means, color these in. The colors of the things with color pie graphs, often coloring them in the color they're supposed to be is actually really easy to view and visualize. If you've got room inside the graph to write the words, like in this case, the black, brown, and blonde, by all means do so. If you don't have room inside, just put the little arrow and point to them and say what they are. Or you can leave them all on the outside. It really doesn't matter. Now, on purposes of a test or anything, I'm going to use about this much accuracy or expect this much accuracy. As long as your measurements are approximate and realistic, that's fine. They don't have to be precise. You don't need to use a compass or anything like that, a protractor, to try and get exact circles with exact number of degrees. I think that's about it, actually. So I think we're going to stop there. This is already a fairly long lesson. But that's pretty much it for representing data. I will say that this is longer than many of the other lessons, so hopefully it doesn't offend you too badly. Anyway, there are some homework problems to give a shot on your sheets. If you'd like to try them, check your answers, make sure you're on the right track. If you've got any problems, contact me. Otherwise, move on to the next lesson and have a fantastic day.